Hello and welcome to this Swift programming video. My name's David Thorne. In the previous video we talked about dynamic dictionaries in structs and classes and how it was a recipe for Swift bugs, quite literally using a recipe class. In this video we're going to be talking all about how we could take this recipe to be a sendable in Swift and making it thread safe. So let's just have a quick look over this one class if you haven't seen it already in the previous video. Here all we have is a private var of steps, and it's a dictionary where the key is a string and the value is a collection of strings, and we just initialize it to an empty dictionary. Now in order to add a recipe we use the add function, and we add the title as the key, and then we add the steps as the value of that one recipe. And then the get steps is just going to return that steps. The get steps for title is then going to return the steps or an optional collection of strings if that one title exists in this steps. And the remove here is going to remove that one value from the steps. And I'm just going to print it out here as well, just for the sake of showing that we did remove it in the event that we actually could remove it. All right. So with that said, I've got now an example down here how we can test it. All right. So we're just using a dispatch group because we've got to wait for all of these operations to occur on the terminal. And we create a dispatch queue, and we're going to make a concurrent queue as well. So first of all, we're going to execute an asynchronous task here just to add pancakes to the recipe. The second one's going to add omelettes, and then the third one here is going to remove pancakes, and then the fourth one is going to add salad, and then the fifth one here is going to check to see whether omelette actually did get added, and if it did, it's going to print out the steps for omelette. And then the final one here, we're just going to print out all of the steps at the bottom. So where are we going to possibly have problems? Well, as you can see here, is that all these asyncs are all going to run at the same time. They might run a little bit outside. They might not run exactly the same time, but all of these tasks are going to get started, and whether they get executed all at the same time. But one by one, these tasks are going to be added to this dispatch queue, and how it's going to cope with it in the background is its own thing. So first of all, we add pancakes, and then we add omelette, we remove pancakes. We're going to have a problem here if pancakes doesn't exist already, then this is where we're going to have a crash here. But if this one did go first, then we can remove it anyway. And then we can add salad because that's not an omelette. And then if we get a step here, then if it's not, then it's going to be optional. And so we don't have to worry about that too much. And then we just print out all of them. So where do you think the bugs are going to be? Is it the fact that when we try and remove pancakes, it's whether it exists or not? That's not where the bugs are, right? So let's just run this to show you, because we can better look at it. And you can see here that it's crashed at add, all right? We can better see it if we start looking at all of these threads, okay? And we can debug it. The thread 1 is of no relevance. That's where the everything is happening. So let's look at thread 2 first of all and keep going down until we see something. We see that the add function got called on the recipe, all right? And we can see here that this is then for pancakes, and it has 3 steps. Let's keep going down, and let's keep going down to thread 3 now. We can see that thread 3 was adding omelettes. Thread 4 was then was removing pancakes, and thread 5 was the one that crashed. So if we just take this first example, like recipe add, and if this is the one, if this piece of code is able to access the when we come into add, this one will be able to add these steps. If nothing else is accessing these steps, then adding that one will be successful. Now, because they're happening asynchronously, this recipe.add omelette recipe could happen before adding pancakes has finished. So the writing, the organizing, the reorganizing in the background that's happening to this dictionary could still be happening for the first call. And then the second call comes in and it says, hey, let's add omelette to the steps now, and it wants to do that. But the whole system is still reorganizing that dictionary to be able to hold pancakes, and then it wants to be able to add omelette. So there's memory in the background that needs to be reorganized whilst we then start trying to come in and write to it again. So this is where the first possible crash is going to come. Now, the next possible crash that's going to come is when we try and remove pancakes. So let's assume that pancakes got successfully added without crashing. And then that add omelette and remove pancakes happened at exactly the same time. So we're saying that this concurrent async task happened successfully without anything else reading or writing to the steps during that. So this was successful. But then both of these tasks happen at the same time. And add then said, okay, I need to then take hold of this one dictionary and add these. But at the same time, remove said, I want to access the dictionary at the same time too, whilst add is still modifying it. So you cannot do these same things. You cannot add, remove, update or delete at the same time within a dictionary because they are not thread safe. So does the problem lie here with that we're doing this all at the same time on different background tasks? No. The problem lies here is that we've got to secure these steps from being modified whilst we're using it, we've got to lock it out from being any items being removed until this steps is reorganized, ready for another transaction. How do we do that? We use dispatch queue in this example, okay? And we're going to say here queue, and we're going to make it private because we don't want anyone else messing with it, and it's our queue. Dispatch queue here, and we're going to give it a label and just say inner and the attributes is going to be concurrent, because we can still do things concurrently. We don't have to do it serial here. All right, so the ones that we can easily fix are these get steps first of all. So let's just take this out and we'll say queue, and this is going to be synchronous. All right, we want that call to be synchronous, and this is now implicit. We're saying return queue.sync, and inside of here, because it's one line, one statement, is implicit to say return steps as well. All right, and we can do this same thing here inside get step, and we can say get step sync, because all we're doing is reading, and this is going to say to the queue, hey, I'm reading now, stop all of the other tasks you're doing and give me access to this one steps, and it's going to return this collection of strings. And because collections are passed by value, it means that it's making a copy on write copy of this one array, and so we don't have to worry about anyone modifying this array afterwards, okay, because it's passed by value. And that's the same goes with this get steps. We are making because it's passed by value, which means when we return this, it can do what it wants with that outside of it, all right? But we need to have exclusive access to this one steps in order to return it. Now the add one this is a bit different. We have to come here and we have to say we want a queue, and we want to do it asynchronously, all right? So we don't want to stop other work being done on this one queue, and we're going to do it asynchronously. However, is that with it being asynchronously, this is going to this add function is going to exit straight away, which means that get steps for title or get steps could also call it, and there would be writing to this one steps and reading from this steps at the same times, which would not allow us to do this once again. So what we've got to do is we've got to add some flags here to say barrier, and what barrier internally is going to do is it's going to, when this code gets executed, it's going to tell the rest of the queue, say I've got control now, and no one else is going to be able to access it. So this sync is going to block right until this code block has exited here, and then this. So when it gets down here, this barrier has now been lifted, and the other parts of this code can work once again on this one queue, right? But all the time it's inside this code block, it can't do that. So now we can safely write to the steps, adding this new step with this title. And that goes to the same now with also this one remove. And so we can say here, remove async, and let's just copy and paste it in there. And we'll come into here once again and say flags, and then a barrier here, and then we will do that there. All right, so now when we run this, you can see here that everything works perfectly fine. Just ignore this. And we can see that it all prints out as it prints out. And all steps, we've got salad, we've got omelette, and because in our code, we added pancakes, we added omelette, we removed pancakes, and we added salad. Okay, so here we have salad, we have omelette, and pancakes got removed because all of this was run now asynchronously, but it was thread safe, showing that this dispatch queue, this internal dispatch queue, handled all access to our steps and it controlled it completely. So with that said, this is how we can take code that would crash all the time, right, every single time that we did this, to something that doesn't crash at all. And so let's just remove this barrier just to show you whether or not we get the crash the first time. And we do. There we go. So you just can see how pertinent it is, and we run it once again and it works perfectly fine. So now we know that this recipe is thread safe, right? Which if something is thread safe, it predominantly is sendable, which meaning that we have we are controlling the thread safe by ourselves, right? But this recipe can be used across different threads, which we are here, right? So even if we create a concurrent one, right, instead, and we just do every other one on concurrent one here instead, and let's just give it a different name. You can see here that we can do everything that we want, and we can create another queue as well and say here queue, we want Q1, that's correct here. And here we can turn around and say for I in recipe get steps here, and let's just say the keys here instead. So we'll just say key here, and now we can say recipe dot remove key. All right, nice and safely. And when we run this once again, you'll see here that we come down the bottom and we don't get any recipes. All right, so because we removed them all. Yeah, we don't get any recipes because we removed them all. And when we come back to the prints statement here, you can see that they're all now removed. And there we just had salad left over and so on. So this is, we can do basically any transaction we want now on this, and we'll know that it'll work perfectly fine. And we come here and we add concurrent here, and afterwards we can say print recipe get steps here, and we add omelettes back once again, and you can see that we can add omelettes back once again, no problem. All right, so with that said, I hope that I've highlighted to you how important it is to keep dynamic properties like this, like a dictionary, like a collection, thread safe, and you can protect it using the likes of the dispatch queues and so on, using async. Make sure you use the flags barrier as well, and when you do any read access like that, make sure you use the queue .sync here instead. There are a few other things that you need to take into account when doing this, but that we'll talk about in other videos. With that said, I hope that you've learned something from this one video. I hope you've got something out this one video. I hope you feel a lot more safer now with knowing what to expect when using multi-threading. If this is the first time you've seen dispatch queue being used, then well done. You know, there's a lot more to learn about it. There's other abstractions that sit on top of that using task, etc. in Swift UI, but I feel it's fundamental to learn how dispatch queue works because it's a very low level thing. So if you do have any questions, feedback or concerns, please feel free to use the comment section down below to start a conversation. Other than that, thank you very much for watching. My name's David Thorne, and I'll see you in the next video. Ciao, ciao, and goodbye.